Are there other components that we didn't get to use that are also really important, or the ones we did are they just the fundamentals that we need since the class is over and we did I think under 10
Yeah.
components. So those are the fundamentals that we need to know.
Yes, those are the fundamental ones that you need to know. And basically, like those are the major ones you work with. So what we did was we spoke on categories of different types of components. So we spoke on the display. So any display you're working with still follow the same fundamental rule as the one we used in our class. So with the sensors, with the motor or motor, in whichever English you are familiar with, and just the different subcategories of sensors that we have for components. So that's the one we discussed about resistors and or everything, push buttons and everything like that. So like that's those components that we discussed are like the general ones. Those are the foundational ones you need. I highly doubt you work outside those. So, and if you were to work outside those, that means you're going to be doing something no longer fundamental, but more on an advanced level, if you get what I mean. So, for you to start out with Arduino, with embedded systems, just like to give you a basic idea of uh, Arduino embedded systems and just basically what you can use for your final year project is just this, if you understand what I mean. Okay, any other questions before I start asking my own questions?
Hello, good evening, sir.
Yeah, good evening.
Hey, this thing we did last week, although my network was fluctuating, I think that was last week, Sunday, that we talked about motors. I don't know, like, were you able to later practicalize the code for the motor or something like that?
So, uh, yeah, I'm going to say my bad because I was busy throughout the week and then I was unable to actually practicalize it. So, what I plan on doing is the same way I did for the essentials class. I'm going to give you a very much detailed uh resource like PDF I'm going to create. I'm already working on it. So with pictures and everything, that if you follow step by step, we'll be able to like get to work with it on your own, see it perfectly. And with the code is also going to be included and everything like that. So if you understand what I mean, I'm very sorry I was unable to work because I was doing different things, especially my company. We're working on Q2. The Q2 is fast approaching. But I'm very sorry, but I'm going to send you a resource that will give you every single thing you might need. I'm going to send it to the group along with it's going to contain pictures also and step by step on how you can get it to work and other examples is going to be. So what I wanted to do with the resources, along with every other thing we've talked about throughout this entire course, all of those components is going to be included into one final project that you guys will be able to like see and work with one on one. Not really one on one, like work with on your own on Tinkercad, and it's going to contain step by step guide and everything like that. But because it's bulky, that's why it's taking my time and I've been very busy throughout the week. So I'm very sorry if you have the heart to forgive me. So very sorry about that. Any other questions? Okay, so I'll take that as the absence of any questions. So it's time to start shooting my own questions. So among us available in this class, how many of us attended the first and second class with Princess? Just okay. Okay, so uh, if I may ask, what was the first topic that you guys talked about? So
Hello?
yes, I'll ask what was the first topic you guys like discussed in class? What was the first topic you guys talked about?
Okay, see, with you or with Princess?
No, with Princess, like the general course.
Okay. I just did an overview of basic electronics with us. How was it first
Okay.
class?
Uh, can you give a maybe the summary of the class so that those that did not attend can maybe understand a little, if possible? Will you be able to do that?
Actually, I will not be. I can't be able to like bring everything in details. I think what we just talked about was. Can you hear me?
Yes, we can hear you. Can hear
I
you.
think what I still remember was we just talked about all these basic physics, electronics. So that's just the little I remember. Yeah, just talks about the
Okay.
electronics. Yeah.
Yeah, that's perfectly fine. At least you still remember. It's about is it 7 weeks or 8 weeks now, and I'm still like
Yeah, I think
remember
second
part
week
of it.
of January. Yeah.
Oh, that's very nice. That's very nice. So this first week of uh, first day in the month of March. Happy new month, everybody. So forgive me for forgetting. So that I see Israel raising his hand also. Like seems like you also have something to add to it.
Not necessarily something to add, but like he said, she we did the introduction to embedded systems and the Arduino, and she explained the Arduino microcontroller, the analog pins, digital pins, the power pins, and basically just the introduction, what we need to, the information that we needed to get started with. So that was what we did in the first class. Then was it first and second class you asked or just first class you asked? Hello, can you hear me?
Yes, yes, I can hear you. I can hear you.
Okay. Yeah, so I said, was it the first and second class you asked or just the first class?
You can also do the second class, like this, like a summary of
Oh,
everything, like
okay,
a
okay.
recap. So
And the second class was introduction to Tinkercad. Yeah, I think that was it. So the interface, downloading Tinkercad, the interface. Then if we want to start a new design, it's circuit. Then the she taught us how to like drag and drop different components, how to search components, how to connect wires, changing the colors of the wires. She mentioned that our circuit should be neat. Then how to run our circuit design. Then the code aspects, because we use code, not blocks. And yeah, I think that's what I can remember.
yeah, that's very nice. I'm clapping for you. I'm clapping for you. That's very nice. You did very good. Did very good. So, continuing from that, that's first and second week, right? So, anybody wants to continue from that end? Like, let's see. Let's not even go so far, because I also have lost the curriculum, so I don't really have an idea of the topics that were taught from the weeks that Princess taught you. Apart from, I know she taught you guys about push buttons, so because I know that was one of the first things discussed in my first class with you guys. Well, in my first class with you guys, I took on sensors, and the number one sensor we talked about was the DHT11. So can anyone tell me, did we later use the DHT11 in our class?
Mm. Hello.
Yes, we can hear you.
I think you said like on that DHT level, like I don't know when you wanted to like practicalize, you said it's not in Tinkercad. I think you use other alternatives for it.
Yes, exactly. Another clap for you, another clap for you. So that's very nice. So yes, the DHT11 is not available in Tinkercad. So we used another alternative, which is also temperature sensor. So the only difference was the DHT11 had an humidity sensor embedded along with the temperature sensor in whatever inside. Then we used okay. The question was in my first class. That's the curriculum. So in my first class with you guys talked about DHT11 and we didn't use it for our practical. So I asked why we didn't use it. And UNIMSIC has answered why we didn't use it. So we also used another sensor. Who can remind me what the other sensor is? So and I know Diamond was in class then. So Diamond, if you can you answer some questions? I know that Abu Bakr has not been in class, so or maybe he has been busy or something like that. So you can go and watch the recordings of the previous classes, so you'll be able to understand what we're actually talking about currently. Because we've ended our curriculum and just trying to do a recap. So this is our last class, basically. So Diamond, Miss Diamond, you have the floor.
Sorry, because I didn't really get what you said.
Okay, so I was asking, apart from the we used an alternative sensor for the practical class when we're doing sensor because we don't get the DHT11 on Tinkercad. So apart from the alternative sensor, I think we did talk about another sensor. What kind of sensor was that? What was the sensor about? And I think we used it subsequently after the sensors class. So can you give us a rundown on the sensor we used?
Okay, I think we use, not that I think, we used ultrasonic sensor. Yes, I think we used the
Okay.
ultrasonic sensor. That was the sensor that we used.
Yes, that's
And
correct.
we,
So yes. So like I want you to explain what the sensor is, how it works, and everything like that.
okay, so the ultrasonic sensor is used to, okay, it has the trig and the echo pin, and one sends out the sound waves, another, how like another one receives the waves when it bounces on the object, like basically. So it's like for measuring it measures the distance between that obstacle and like from where the sensor is to the obstacles. So it measures the distance. And what else? What else? I think that's
Okay, yeah, that's all right. So that's okay. Let's be able to give a basic explanation on what it is. So the ultrasonic sensor did mention sends out the sound waves in I think a 15-degree cone-like angle, so it's able to pick up these sounds of up to like 200 centimeters on a normal day. Yes. So and uh that's four pins to be exact, but two major ones. So we have the live, which is the 5 volts, we have the trig, we have the echo, then we have the ground pin. So but those are the normal power connectors that we are following that way, so I can give that point to you. And yes, basically we were able to work with the ultrasonic sensor in several ways, really working with the LCD to display distance, yes, and able to update distance readings within seconds using the Arduino's clock speed and other things like that. So uh, that's I think seems like we all understand the sensors part of the equation. So the next thing we talked about was displays. So talked about LCDs, which are liquid crystal display. So can anyone give us a rundown on what LCDs are and how they function? Like anyone? Okay, Israel, you have the floor.
So, you said liquid crystal display. So I think they are used to display characters, and we the one you taught us was 16 by 2. Yeah, like it has 16 row, and in each of the liquid crystal display, in each of the row, like you can have up to like 16 characters, and it has I think 5 by 8. Yeah, 5 by 8 matrix for each character, and the way it is connected, like normal it has 16 pin, but and the type now is it was I2C, like inter-integrated circuit, something like that. So now with the help of that, like they now reduce those 16 pin to 2 pin, which was SDA and LC. Is it LCA? Yeah. So with the aid of that, we'll be able to connect the LCD to the Arduino board. And then the LZA is the one that like read or write the I think it's the one that read or write the data that send the data from between the Arduino sha. Yeah. So that's the little I can explain. Can you hear me, sir?
Yes, yes, I did hear you, and that's nice. Like at least you were able to understand the class to give an explanation based on your own understanding. So yes, you're correct. You're correct. So and it's SDL. That's the standard clock. The clock lines. So rather than LCA. So it's SCL. So and that's correct. So the I to C communication protocol is here, so you'll be bordering with 16 pins and 16 connector pins on the LCD, everything like that. Yes, a 40 40 pixel matrix for each character display, and that's a 16 column 2 row character ensemble that the LCD will work with us. And the general LCD, that's what you'll be working with in embedded systems most times, and Arduino most times. That's it, like the no, normal one you'll be working with. So then again, that's basically it on LCDs. We talked about addresses, then we talked about the memory types that LCDs have. Then we talked about usually how to work with custom characters, how to write the code for LCDs. We talked about what do we talk about again? Let's talk about the amount of characters. I think 256 characters are stored inside the memory of an LCD. Talked about how the I to C communication works and how they behave. Is it behave? I'll say, yeah, how they behave and everything like that. So yes, that's basically what we discussed about on LCDs and everything like that. So we also did talk about yes, talked about multi-screen display on LCDs. That's displaying multiple screens on one LCD. I think we did practical on that where we had 3 screens, one for temperature, one for distance, and one that was doing the statistical calculations that we did in min, max, and average. So that's where we connected the LCD with the sensors, both sensors, the temperature and the ultrasonic sensor. We able to work with that. Yes, that's basically what we did in LCD. They talked about motor or motor, depending on your English. Who can give me a quick recap on what motors are and how they help in embedded systems? So just general, what motors are generally. So anybody, or should I call name? Should I call names? Okay, yeah, Israel, go for it.
Okay, so what I can say about motors is the different types and their differences. So we spoke about stepper and servo motor. Then the main difference, and they work based on gears. And the main difference that I remember between the two is for servo motor. So you basically, I mean, how do I put it? Okay, for servo motor, you move the fin by a certain angle, while for stepper motor, you move to a particular angle. I don't know if you get what I'm saying.
Yeah, yeah, I
For
get what
servo
you're just
motor,
saying. So,
you move the, let's say, actuator by a certain angle, while for the stepper motor, you move to a certain angle. So by an angle to an angle. So that's what I can remember.
okay, yeah, that's nice. Does anybody want to help him continue? Anybody wants to continue? It seems like nobody wants to continue. Mr. Mount, how would you like to continue for Israel? We stopped or just buttress this point.
So I was not in that class. So that's why I really can't like say what was discussed.
Okay, okay.
Same
So
here too. I was in the
uh,
class, but my network was bad that day, sha. And she has not dropped the recording, sir. I haven't tagged her on the group for the recording.
oh, so yeah, I, I will talk to her so she will drop it. So she will drop it. Okay, so for the mottos, we talked about the two types of motto there are. So, talked about the stepper and the other one. What's the other one's name again? Oh, this other motto again. I think stepper and the speed motto. Yeah. So, I think that's it. Is that enough? So, but okay, we talked about the two types of motor. So, we talked about the two types of motor, and we talked about the way motors work, the way both types of motor work. So, and how they work and everything like that. So, okay, so it's DC motor, not speed motor. So, forgive me on that. So, yes, talk about the way both motors work, how they generate their speed, why the stepper is good for which which thing, and why the other one is good for its other thing, and everything like that. So also talk about if you need speed, use the DC, because what you just need to do is just like send more current into the motor, and sort of like keep spinning, like we're going to keep going faster, and we use control. Uh, I did ask a question in class, and someone did answer that PWM was pulse with modulation, which was correct. And talk about stepper motor and their how they work in steps, how they have several cores. I think I did show pictures of the different inner workings of the motor and everything like that. So yeah, I think we did. So so like we did talk about it. So again again um, yeah, that's basically it. So any questions like generally, any questions? Okay, Diamond, ask your question.
Okay, so how about the seven motor? Is it also the
Seven
DC
motor.
or yes?
So, I don't really understand what you mean by seven motor, but I know the two types of motor are stepper and DC. So maybe the DC is what you mean by a seven or something like that. But the DC is the normal motor that everybody is familiar with. That one that you servo. Oh, I thought you were saying server. Oh, sorry. So I'm very much sorry. Very much sorry. I couldn't hear you very well. So uh a servo motor is kind of like is I think it falls under the I think it falls under the category of like the stepper motors because it's also like kind of the same thing. But what they are more is like more of linear actuators. So what that means is uh we have three controls: power, ground, signal. So uh it uses this kind of it's using the same principles as the stepper motor to actually get the proper angle and everything like that. So like that's basically it. So do you understand?
Yes, yes.
Okay. All right then. So any other thing? Any question? Any other question? Okay, Israel, ask away.
Okay, so it's not really a question, it's more of like a quick favor. So I was not able to stay long for last week's class and the recording is not out yet. So I feel I'm missing out on something. So if you can just give a brief summary so that I can at least have something in mind till the recording drops. So maybe just in a minute or two, just briefly explain what you did last week as class.
Okay, so no problem. I will do that. So last week we talked about motors, everything. So same thing. So what we talked about was electric motors and their principle. So first of all, we did mention that motors work by generating like it's like a coil, yes. Electricity moving through a coil between two magnets, generating an electromagnetic field through north and south pole that causes the coil to spin at a very high speed. So like that's like the general principle of how motor works. So uh yes. So after that, I think what we did talk about is this thing again. Talked about the types of motors. We talked about the stepper motor and the DC motor. So he said the stepper motor is a kind of motor that are position controlled, meaning that uh, everything you want to do, maybe let's say in the project you're trying to build, you need control. So you use a stepper motor. So what that means is, okay, I want to build, let's say, a robot that, let's say, needs to move at this particular step. So we need to control the step. We use a stepper motor for that. So yeah, for a proper robot, I doubt you use like this kind of like with drawback explanation. It's like kind of basic explanation, but we get the point I'm trying to put across. So yes, then talk about DC motors. DC motors are just like normal motors that work on the principle of speed, meaning the more power you add to it, the faster it spins. So for the stepper motor, so as I said before, they are position controlled, meaning if you say, okay, you guys move exactly 200 steps clockwise to do that, So, but DC motors are like speed control. So, like I say, oh, you move 100% of its speed, 50% of the speed, depending on how much current it goes through to the motor. So then precision, that's another thing that differentiates between both motors. So like DC motor can spin very fast. I'm sorry, a DC motor can just spin continuously. It cannot control anything other than its speed. So if you want to control exact position, you need additional components, additional sensors, and at the end of the day, it's not really still like as accurate as when you use a stepper motor. So, but stepper motors, what they do have is 200 steps per revolution, meaning that's 1.8 degrees per step, and that means you can exactly position things the way you want it to be. So, because you can do the calculations and everything all the way. So, yes, real world examples. For those that are not young, you know that DVD tray opening, that tray that moves the DVD. So you know when you click on open on the DVD button, sorry, on the DVD, there's that place that you put your disc after you wash it with soap or use whatever you want to use to clean it when it's cracking. That thing opens with a certain amount of distance and stops. So this motor won't work the exact same way because this motor is just not for just spinning continuously. So it can't really stop at a particular distance or do anything like that. So they use a stepper motor to control how like how much they want it to spin for whatever distance and all like that. So yeah, that's and then you know where this you see DC motors like fans, just every fan in general, computer fan, your handheld fan, if you're feeling it and everything like that. So did talk about some concepts on how the stepper motor works, but since I'm unable to like to show pictures and everything like that, it's gonna be better for you to watch the what do you call it, to watch the recording on that, because that's where I did explain in detail on how the stepper motor works, was kind of complicated and everything like that. So and also did the same for the DC motor. So yeah, that's basically it. Then talk about drivers. We said because you can't just connect the stepper motor. Sorry, you can't just connect motors to your Arduino. You need drivers to get it to work. So I also did show the driver, the calculations, like yeah, not really too much calculations, but yeah, those they had this kind of complicated twist way that you need to get without pictures. So everything like that is explained in the class. I'll ask Princess to drop the recording. So she has been very busy. So that's something to any other question? Just any other questions? Any questions? Okay. I'll take it as 0 questions. Okay, you're welcome. No problem. So, can we end today's class the way it is, or do you want us to touch on other things? Because if you want us to use the remainder of the 2 or the 1 hour, we can always use that discussing different things you guys might want to discuss. But if you also want us to end the class, we can always end that. Okay, Israel. Floor is yours.
A question I want to ask. So people talking about, you know, the
Sorry, Israel, I can't really hear you. Sorry, I couldn't really hear you. I couldn't hear you.
Can you hear me now?
Yes, I can hear you now. Yes.
Okay, so I was saying it's a request, suggestion and request. So I hear people talking about and actually doing Arduino projects. where they buy materials, they build stuff like um like motion detection doors, stuff like that. So do you have a website where we can actually get a guideline for projects like that? Maybe not so complex, but something like a roadmap. We'll start with something
Yes,
simple, we get something complex. So something. Do you have any recommendations so that we can just keep working so
yeah,
that we're not
yeah.
forgetting?
I can get you that. Yes, the Arduino website. Yes, the Arduino website in itself contains tons of projects that you can work with. So, and Tinkercad itself, while Tinkercad does not have the tutorials, what Tinkercad has is Tinkercad has more of a platform. It's more of a, it's Tinkercad is more of a platform where you can practice some components out and try your hands in coding and everything like that. So, but yeah, the Arduino website. I'll send you the website on the group because even though we are done with the class, you can always drop any questions you have on the group. Come to my DMs, always open and anything like that. So, uh, if that's going to be all right. So I'm going to drop the group call. You can also check out the Arduino website on its own. It's in its own right. So, any other questions, or do you want us like just discuss random things to end the class? Just at the class now. So, like, should we just keep watching each other in silence? Okay, let's go. Floor is yours.
Sorry, me again. So the question is, so after this class, like, what next? What did we do next after this? Aside trying to figure out projects to work on our own, like, what would you suggest we do? What's the best line of action after this
So,
classes?
I don't know if Princess has told you. Yeah. So, I don't know if Princess has told you, and if she has not told you like this, like just like giving you hints. So, uh, I'm taking embedded systems. There's also going to be another topic apart from embedded systems. I won't really say the topic, but it's going to be something related to embedded systems. So we just talked about embedded systems in its own right. So it could be CAD, it could be industrial automation, it could be just it's something on that right. So in the meantime, still going to drop you guys assignments. The problem is I've been very busy, especially this week, as I said before. So I've been very, very busy and I've not even had time to even processed anything about the class. We were even supposed to have this class yesterday, but I forgot about it because I was doing something else. I'm very sorry about that. So I will send the assignments, and the price is also on ground for anybody that remember if that we talked about the price. Yes, we did talk about the price, and it's still available right now. So yeah, so you guys can practice on your own or send the assignment that you're going to work on for several weeks before. I don't know when your class is going to start. I think it's this month. Is it that this month or towards the end of this month? I'm not sure, but places just want to give you guys a break. That's because of you guys are some people are having exams, people are going for their final year project and everything like that. That's plan currently. Is that cool, with you guys? So any other thing?
So I want to ask this assignment you want to give now. After finishing up the
So
assignment, how do we get to submit the assignment?
I'll take it that that's all. So uh
Hello?
yes, I'm with you. I wanted to say something.
Okay, I said after when we are through with the assignment, how do we get to submit? Will there be
Okay,
a
so
link or
yes, I'll drop a way you guys will submit. So yeah, there's no problem with me dropping. Maybe if you want guys want to drop it in the group, or I'm going to submit do a poll, sure. So for anybody that wants to submit through a Google form, or if it's a link, or if it's a Microsoft form, or if it's WhatsApp you want to use. So we're going to give you guys the opportunity to pick. And if you guys have different opinions about the different ways of submission, I will create different submission portals and everything like that. So don't worry about that. That's will cross the bridge when we get there. So any other thing? Any other thing? Anything? Or do you guys need advice outside our class or outside embedded systems? We just have like general questions. Just feel free to ask. So it's not necessarily about the class. Just any general question you might have about tech, anything. Just ask. Okay, is there? Go ahead.
Okay, so my question is, how do we actually end up making money from learning Arduino? Like I know Arduino is not it's not everything. Like you see progress, but when we eventually start getting money, because we get money university, what do they actually do in companies? Is it that they design the circuits and actually build prototypes, or what do people actually do in companies with embedded systems and Arduino?
Well, to bust your bubble, people that I see that work majorly in embedded systems don't really like work with Arduino. So they do work with or other microcontrollers. So and what they do most of the times is they design a circuit for different industrial uses. So just uh, general most times they're just designing circuits for use in everyday objects, like circuits for let's say your toaster, uh, circuit for a robot, circuit for industrial machines, just like general circuit. Arduino is like the lowest of all. Like nobody really reads Arduino in the industry apart from students. So I was like, that's a red flag. But Arduino is like a great piece of resource to teach students about embedded systems and the things like to generally expect in embedded systems. If you get what I mean. So and you can make money by like well working in organizations that build out what they call it, that build out platforms. Is it platforms are called? Build out products, hardware products for industries, supply chains, and everything like that. So you work with other guys hand in hand. So some guys will work on maybe let's say you're working on a toaster, you guys work on the circuit, another guys will be working on the part. So but not really a toaster, but you get what I'm trying to say. It's like those little tiny devices are as circuits in it are actually needed. You guys. So are you guys work with professional grade equipment, not with DHK11? So you work with other ones if you understand what I mean. Okay, Diamond. That's clear. Close yours.
Okay, so my question is that how can someone actually like measure, like how can you measure growth like in this like Arduino and embedded system? Like how can you actually measure that okay you are growing, like you are doing better than before?
So the way you can measure growth in I'm not going to talk about Arduino, I'm going to talk about embedded systems in general is when you can use professional grade equipment and tools. So you're starting out from Arduino, you already know what sensors are, how to work with sensors. So if you can take this general understanding that you have right now and like just take it up a notch and give and let's say work with ESP32, a Raspberry Pi, using the same concepts you've learned from work with an Arduino. That's growth. So you won't actually know until you like try your hands on different other, it's not, is it equipment, I'll call it, or professional grade components. So something that is used generally in the industry rather than just a student grade materials. Because another way you can measure growth is if you can write cleaner C++ code. Yes, because that's going to be your life, writing code, C++ code, and everything like that. So if you're able to like write cleaner C++ code, able to maintain or understand other C++ code you've seen, yeah, that's super good right there. So any other question? So like since there are no questions, seems like we have to end the class. So it's been nice teaching you guys. So I'm sorry if my teaching is not up to par or what you might expect, because I'm not really that much of a great teacher, but I did try my best. So, and we are still going to meet again. So, after you are done with your other course, I think I'm not going to see the topic. So, after you're done with that other, your other class at the Wolf, another confirmation to have and everything like that. So, it's nice knowing you guys. I think we'll end the class now since everybody is you guys don't have any other questions. Does anybody have any other question? Any other situation or anything? You can just simplify by putting that plus button up there and that like button. So if it's not, you can just like end the call, somebody go on the way. Arsenal fans gonna rejoice, Chelsea fans gonna cry, and everything like that. Okay, take that as a no from everybody. So have a great week. Happy new month. And I hope the next time we'll meet, uh, everybody will be some form of experts, as I would like to call it, and will graduate from studentship, move to greater components like the ESP32, Raspberry Pi, everything like that. So as I said before, I'll get you guys the resources, yeah, your assignment, and the price is still on. So I wish you a great week. For those having exams, wish you good luck in your exams. For those that are doing their final year projects, I wish you good luck. Your lecturer will not cancel your chapter 3 in Jesus' name. And so every other person that is just free for the sake of being free, go and find something to do with your time. And let's go and do something. Nigeria is not smiling. But have a great week, everybody. And good night.